Fossil fuels are a crucial component of modern energy consumption, providing the primary source of power for industries, transportation, and homes worldwide. The formation of fossil fuels is a complex process that spans millions of years, involving various geological and biological factors. These fuels, including coal, oil, and natural gas, originate from ancient organic matter subjected to heat and pressure over geological timescales. The process begins with the accumulation of organic material, primarily plants and marine organisms. During the Carboniferous period, approximately 300 to 360 million years ago, vast swampy forests covered much of the Earth's surface. The dense vegetation in these forests, consisting of ferns, trees, and other plant life, would eventually become the primary source material for coal. In marine environments, microscopic organisms such as plankton, algae, and zooplankton thrived. When these organisms died, they sank to the ocean floor, contributing to the organic sediment that would eventually form oil and natural gas. As these plants and marine organisms died, they were buried by layers of sediment. In swamps and bogs, the dead plant material accumulated in thick layers, forming peat. Peat is a spongy, waterlogged material that marks the initial stage of coal formation. In marine environments, the organic matter mixed with mud, silt, and sand, creating organic-rich sedimentary layers. Over millions of years, these layers of sediment continued to build up, burying the organic material deeper underground. As the depth increased, so did the pressure and temperature. The heat and pressure caused the chemical composition of the organic material to change through a series of complex reactions. In the case of coal, the process is known as coalification, while for oil and natural gas, it is called catagenesis. Coalification transforms peat into different types of coal. The first stage of coalification is the formation of lignite, also known as brown coal. Lignite is soft and has a lower carbon content compared to other types of coal. As the lignite is buried deeper and subjected to more heat and pressure, it transforms into bituminous coal. Bituminous coal is harder and contains more carbon, making it a more efficient fuel source. With further burial and exposure to even higher temperatures and pressures, bituminous coal eventually becomes anthracite, the hardest and most carbon-rich type of coal. The formation of oil and natural gas follows a slightly different path. As the organic-rich sedimentary layers are buried and subjected to heat and pressure, the organic material undergoes a transformation known as thermal cracking. This process breaks down the complex organic molecules into simpler hydrocarbons. The specific conditions, such as temperature and pressure, determine whether the hydrocarbons form liquid oil or gaseous natural gas. Generally, oil forms at moderate temperatures and pressures, while natural gas forms at higher temperatures and pressures. The migration of oil and natural gas is another critical aspect of their formation. Once formed, these hydrocarbons are less dense than the surrounding rock and tend to migrate upwards through porous rock layers. This migration continues until the hydrocarbons are trapped by an impermeable rock layer known as a cap rock. The trapped hydrocarbons accumulate in reservoirs, which can then be tapped for extraction. Several geological structures can act as traps for oil and natural gas. One common type is an anticline, a dome-shaped fold in the rock layers. As the hydrocarbons migrate upwards, they become trapped at the crest of the anticline. Fault traps occur when a fault line creates a barrier to hydrocarbon migration, allowing them to accumulate on one side of the fault. Salt domes, which are large, buoyant structures of salt that have pierced through overlying rock layers, can also create traps for hydrocarbons. The extraction and utilization of fossil fuels have had a profound impact on human society. The Industrial Revolution, which began in the late 18th century, was largely driven by the availability of coal as a cheap and abundant energy source. The development of the internal combustion engine and the widespread use of oil and natural gas in the 20th century further transformed industries, transportation, and daily life. However, the reliance on fossil fuels has also led to significant environmental challenges. The combustion of coal, oil, and natural gas releases large amounts of carbon dioxide and other greenhouse gases into the atmosphere, contributing to global warming and climate change. The extraction and transportation of fossil fuels can also cause environmental degradation, such as oil spills, habitat destruction, and water pollution. In recent years, there has been a growing emphasis on transitioning to renewable energy sources to mitigate the environmental impact of fossil fuels. Solar, wind, hydroelectric, and geothermal energy offer cleaner alternatives that do not produce greenhouse gas emissions. Advances in technology and changes in policy are driving the shift towards a more sustainable energy future. Despite the push towards renewable energy, fossil fuels are likely to remain a significant part of the global energy mix for the foreseeable future. The infrastructure for extracting, processing, and distributing fossil fuels is deeply entrenched, and transitioning away from them entirely will take time and substantial investment. Efforts to improve the efficiency and reduce the environmental impact of fossil fuel use, such as carbon capture and storage technologies, are also critical components of the broader energy strategy. In conclusion, the formation of fossil fuels is a complex process that involves the accumulation, burial, and transformation of organic material over millions of years. Coal, oil, and natural gas each have distinct formation pathways, but all share common elements of geological and chemical change under heat and pressure. While fossil fuels have been instrumental in powering industrial development and modern life, their environmental impact necessitates a shift towards cleaner, renewable energy sources. Understanding the origins and implications of fossil fuel use is essential for navigating the challenges and opportunities of the global energy landscape.